Hello everyone, welcome to the 11th lecture of the Python programming series. In today's lecture, we will learn about object-oriented programming in Python. So let us start with the lecture. So the learning objectives of today are we will understand what is the concept of object-oriented programming, what is the difference between procedural programming and object-oriented programming, that is OOPS, and we will understand the difference between classes and objects. We will understand how to create classes and objects. We will understand how to use constructors, and we will work with instance variables and methods. We will understand what is self keyword. We will learn about the four pillars of OOPS, that are encapsulation, inheritance, polymorphism, abstraction, and at last we will try to build a real world application using OOPS concept. So let us start with the recap of the previous lecture first. In the previous lecture, we learned about file handling, exception handling. We learned about try and accept CSV files, JSON files, and now let us start with this lecture. Now imagine you are building an online shopping website and that need customers, products, orders, payments, and employees. Can we manage everything using only functions? The simple answer is not efficiently. Why? Because that will not be able to do the stuff in a right manner. So that is why object-oriented programming exists. OOPS helps us to organize our code into objects that represent real-world entities. So what does OOPS means? What does oops mean, but why we cannot manage only with the function, and why we need object oriented programming. We need object oriented programming because oops helps us to organize our code into objects that represent real world entities. So that is why we need object oriented programming. So what is object oriented programming? The simple definition of object-oriented programming is object-oriented programming is a programming paradigm that organizes code using objects and classes, classes and objects. So an object contains data, behavior. So what is data here? The data here is attributes and behavior means the methods. So it organizes data and functions, or you can say methods, attributes and methods. So instead of writing everything as function, we group related data and functionality. So this is known as object. What is object? The group of related data and functions are known as object. That is the another definition of object. I will explain this, but let us see some real life examples so that you can get a more exposure and understanding what is object. So here are some real life examples. Firstly, let us take the example of car. So in car, we are having some attributes as well as we have some methods. So what are the attributes, or what the attributes may be? So attributes are nothing but the data. Anything that can be grouped as data, that is known as attributes. So what can be the data? Brand name, color, speed. So this is type of data. So this is known as attributes. Anything that is like and that provides some knowledgeful insights, that is known as data. So the data is known as attributes in objects. And after that, what are the methods in a car? We can start it, we can stop it, we can accelerate it. There may be many more, but we are just understanding the basics to understand what is object. So, what do you understand from here? This is a simple meaning that attributes means data, and any functionality of something is known as method. So this is the simple meaning, simple real life example. Now next, let's say we are having example as student. So what are the attributes in case of student and what are the methods in case of student? Firstly, in attributes, a student will have name, roll number, age, admission number, parents name, contact number, many more things. And what are the methods? What are the functionality of a student? A student functionality can be study, attend the classes, give exam. So these are some of the functionalities of student. So I hope you are understanding that what is object. So object means nothing. Let's say this is the object. This is the object. Okay. So what is object? It is collection of two things. Two things are there. First of all, what is inside that? The first thing is attributes and the second thing is methods. Okay, what are attributes? Attributes means data and methods means functionality. So this is the simple meaning of object. So what is object here? Object contains two things. First attributes, second methods. So what is attribute in simple terms? Attributes means nothing but the data. And what is method? Method means nothing but the functionality of any similar thing. Like the now one important thing is there that the data and the functionality should be related to each other. Then only they can be object. So this should be related to each other, each other. So this information, the data and the functionality means the attributes and the method should be linked, should be related one. Okay, so this should be related to each other. Then only we can say that it is an object. It is under one object. So we are having one more example here. We are having the example of mobile phone here. So what does this example specify? In a mobile phone, what can be the data? Data can be the RAM, what is RAM, what's brand of that mobile phone, what is the storage, what is the screen size, what is the battery capacity, and what is the charging capacity, how much watts are required to charge it, and many more things are there. So that comes under attributes and data and data comes under attributes. That is a simple meaning. And what are the methods? There are many functionalities of the mobile phone. We can call, we can use camera, we can charge, and way more things. You can watch YouTube, browse reels, many more things. So this is something related to each other. What is this data? This data is about mobile phone. So what are the functionalities? What are these functionalities telling? This also refers to same thing, that is mobile phone. So the data is also mobile phone. The functionalities, the methods are also mobile phone. So we can say that mobile phone is an object. So I hope you understood what is object now. Now the next thing is, why do we need OOPs? Why we need OOPs? Suppose we create a student management system without OOPs, what it will look like? Just see here. We will have, let's say, one variable is there, student one underscore name equal to Rahul, student one underscore age equal to 20. So we are having one variable like this. After that, we are having another variables. Student 2 underscore name is equal to Priya. Student 2 underscore age is equal to 21. As the number of students grows, the code becomes difficult to manage. Now, what will happen if I say we have to store the data of, let's say, 1,000 students? We can't write like student 1 underscore name age, student 2 underscore name age, student 1,000 underscore name and age. This will not be the right method to do that. So that is why we use oops. So what will happen in oops? We will create a object of that. We will see how we'll do that, but it will look like this: student, then the name and age, then again student name and age. It will be cleaner, reusable, and scalable. Now, firstly, let us understand there are two types of language. The first one is procedural. The first one is, sorry, so yes, cut start. So there are two types of languages. So the first one is procedural programming language, and the second one is object-oriented programming language. So what does procedural means? What does object-oriented programming means? We will understand in the depth now. So let us start with procedural programming first. So what does procedural programming means? The functions are primary and it is difficult for large projects and it is less usable, less organized. Data and functions are separate. So I will explain you in simple terms what is procedural programming language. Procedural programming language. So what does this mean? This means nothing but just remember one thing, that in procedural programming language, the stress is given on functions. Functions. So the stress is given on functions rather than data. So data is unorganized in these types of languages, and it the functions are the main thing in this. So the stress is given on functions rather than data. That is the simple definition, the very basic definition of procedural programming languages. So what are the example of procedural programming languages? We are having C as the example of procedural programming language. So in the C language, what happens is the stress is laid on functions. There is no concept of encapsulation, abstraction, polymorphism, or like that. The OOPS concepts are not applied in C. So there what happens is the stress is laid on functions, means the functions are the primary things that are referred there, and the data is not managed efficiently there. So that is what it is mentioned here, that functions are the primary things and it is difficult for large projects because we are not managing data. We are just laying leading we are just laying our attention on the functions only. So that is why it is difficult for large projects. It is less reusable and it is less organized also, and data and functions are separate, and their data is separate thing and functions are the separate, so that are not correlative. So now let us understand what is object oriented programming. Objects are primary, better for large projects, highly reusable, well organized. Data and methods stay together. So what does object oriented programming means? So in object oriented programming, we we group the related functions and data. Like we see in object, what is object? Object is group of related functions and data, means attributes and methods. So in object oriented programming, the stress is laid on data rather than functions. So we are having functions also in this, but we put a stress on data more than functions. It means that the data is highly efficiently managed here, and this is a better approach for coding, for programming. So just see over here that objects are the primary thing in object-oriented programming, and these are better for large projects. Why? Because the data is managed efficiently, more efficiently than procedural programming language, and it is highly reusable. Why? Because we create objects that can be reused anywhere in the code, and after that, the it is well organized and data and methods stay together. It that means the concept of objects. What is object? Object is nothing but the group of data and methods. So that is written here that the data and the methods stay together. So the next thing which we are having is part B of this lecture, that is classes and objects. We know what are objects, but we will just see the another definition here now. Let us start with the class first. Now, what is class? A class is a blueprint or template for creating objects. Now, what is class? Class is a blueprint of object or a template for creating object. Well, it is a very basic definition which everyone knows, that a class is a blueprint of object or for creating the object. But what class actually is, let us understand. Now, think of a class as the design of a house. The actual house built from the design are objects. Now, think of the class as a design. Now, we are having design before making the house. So, we see the design and then create a house. That is written over here, that this is the actual house. I will write it here, actual house, and this is the design over here. So this design is referred to as class in this example, and this is referred to as object. We will understand this how. Now, we use this design. Design means a blueprint of something, like a sketch of something. And we will follow this design to create that house. And that actual house is known as object. I hope you are understanding that. What is the meaning of that? A class means nothing but a sketch, a rough sketch, or you can say a template on which the foundation of objects is laid. So that is the simple. Let us understand with the example first. So let us understand the syntax of it. How we are writing, we will write class. After that, the class name. Here it is written student. We will write name over here. Any name we can write, and then colon, and then with the indentation, just write whatever you want in that. Now, now what is object? An object is an instance of a class. Instance means at a particular time it holds some particular value, data, and function. So that is known as object. So we are having the example here. We are having a blueprint. In same in the case of that house, that we are having a design first, a blueprint first. After that, car design is there, a blueprint is there. After that, car is designed, and then actual car is made. Now, the actual car is the object, and the blueprint from which the car is made, that is known as class. So, in simple language, let's say these are some rules. Some rules are there, or in simple language, we are having blueprint. So, we are having some rules or some blueprint on which we create some objects. The objects are the instance of these classes that hold some specific value, and I hope you understand this. Now, we are in one example here. We are having class here, class student, and we are just not writing anything. We are just passing it out, and after that, after coming outside the class, we are creating the object. So, how to create an object here? Let us understand. We will give any variable name. Let's say here s1 is given. After that, we will put equal to, then the class name we will write here. Student is the class name. We will write student. After that, we will just put parentheses. So this is how object is created. Now, student in this is class. This is the class, and s1 and s2 are objects, and this is known as objects. So this is how a class and object is created. So whatever we write in this, that will be the blueprint, or we can say rules, or we can say blueprint. And on that we will create some objects that will hold that rules, whatever is written in the class. We will understand this with the upcoming examples as well. Firstly, let us understand what is a self keyword. So one of the most confusing topics for beginners is self keyword. Self refers to the current object which you are dealing with, that is known as self. To call that object, you need self. So for example, we are having class student and we are having function def show self print hello. So here def show self inside the class means that particular object. So that object is passed over here and we are just printing hello. So I am in the VS Code and I have created one folder here, lecture 11, and in that folder I have created one file, classes and objects.py, and in that file I have written some code here. So let us understand this code first and then we will try and run this code. This is a very simple code written over here. Let me explain that first and then we will run this out. So I have done nothing but I have created one class with the name student, and after that in that class I have created two functions over here. The first function is study, and in that I have passed a variable, a parameter self, and I have created another method, another function, attend classes, or you can say attend underscore class, and in that I have also passed one parameter self, and in both the methods I am just printing a line, a string I am printing. So this is a simple method. The methodology should will be different, but I have just printed over here to understand the concept of classes and objects. Now, what does self means? Self refers to the current object. Whatever the object will be calling this function, so that object's values will be taken. So that object will be referring to self. So we are creating object here. We are creating student one, and so student one and equals to student, and student two equals to student, and after that we are calling the methods. How we are calling? We are writing the object name, then dot, then the function name. So this is how we are creating the calling the methods. So for both the objects, we are calling the same methods. So when I run this, simply I will get both the time same result. But I will explain you here. So like you are writing parameters in functions, same way you can write here also. After self, just put comma, and after that you can write the subject name. It is suggesting a subject, so let's go with subject. And after that, I will just change this to this. And what I have done here is it is we have passed one parameter subject and we have converted this print statement into a f string, and we are printing the subject name as well. Same way I will do for attend classes also. I will write here something, comma, then class name, let's say, and we are printing student is attending, then class name. And we are passing in the object like this. This is extra. No. Student one dot study, student one dot attend classes, and student two dot study. Okay, fine. So this is what we are doing. Now, what is happening? Let us run this. So wait. Yeah. So what will happen now? The student one in student one we are passing the subject as mathematics in both the functions, and in student two we are passing subject as chemistry in both the functions. Now, when I run this code, first two lines will display mathematics, and second, the next two lines will display chemistry. Why? Because in the second object we have passed the parameter, argument as chemistry, and in the first object we have passed the argument as mathematics. So this self means the current object. So when we are calling this we are calling this object with the function or with the method and pass something that that message the sorry that argument is refers is stored with this object, and this is passed over here. That self means the object. So that is why we are getting different outputs. So now the next thing is constructors. Now firstly, what are constructors? Constructors means nothing but the function to initialize the starting values of the variables, or you can say the attributes. So now what is the definition of this? A constructor initializes an object when it is created. So what is constructor? Constructor initializes an object when it is created. It initializes the variables of that. So what is the syntax of this? This have very simple syntax similar to that of function only. You just need to write def, that is initialization or creation of function. After that underscore underscore init underscore underscore init, then again underscore underscore, and inside the bracket you need to write self and just enter into this function, or you can say this is a constructor now. So what is constructor? You have to use the function name as this underscore underscore init, and inside that you need to pass self, and then whatever you write inside that, it will be done at the starting or the creation of the object. Now what is the use of constructor? So what I will do, I will open ChatGPT. I will go to ChatGPT and say it to explain constructors in Python. So I will just say over here. So I will just write explain constructors in Python. So it has given me something. So it said that a constructor is a special method that is automatically called when an object of a class is created. It is used to initialize the object's attributes. The constructor in Python is defined using the init method. So, what is the meaning of that? Constructor is a special method that is automatically called when an object is created. So, what I have said you earlier, that an object constructor is a function, a type of function that is automatically called whenever object is created in a class. Of a class is created, an object of a class is created, then and there the function that is constructor is called. So this is the difference between a function and a constructor, that a function is called whenever we call a function, but a constructor is always called by itself only whenever we create any object of that class. So the constructor in Python is defined using init function or init method. What is the syntax of that? You are having a class, and in that class you are writing def, and after that you are writing init function, that is constructor, and then you are writing self. Self should be written in every function whenever you are writing inside the class, and after that you can write parameters as well. You will see the with the parameters later, but for now just see that you are having self only, and after that you can specify the initialized values of the attributes. So this is how constructor is used. The use of constructor is only to initialize the values, the starting values. For example, we are having here def init self comma name comma age. So this is with the parameters. So let us try creating without the parameters. Then we will see this example. I will create a new file over here. I will name it as constructor.py, And after that, here I will write, let's say I will write class student. It is auto suggesting something, but I will ignore this and I will write a simple example over here. Here I will write def underscore underscore init, and after that I will just pass self over here, and let's say we are having the variables self dot name is equal to, let's say, empty, and after that self dot age is equal to 0. So this is the basic. So I am ignoring it because I do not want to use the parameters over here. So this is how I have created something. So these are the variables, or you can say the attributes, and I have set a default value for that. So whenever I try to create an object, let's say I create here s1 is equal to student. So whenever I create this, automatically these values will be created in the backend. So when I try to print something like I'm trying to print s1 dot name, so here when I try to print it, and after that I try to print age as well, let's say I am printing age as well. So when I run this, I will get output as this is empty string. So this the line is printed empty over here, and after that we have initialized this variable to 0, so we are getting 0. So you can see here we have not created any variable over here. We are just created the object over here, and after that we are just printing the values. So this is how it is working. So it is only possible if we use the function name as init. Init means the constructor. Constructor means to initialize values. So this is how the values are initialized. Now, if you want to initialize it to some user given values or some other values, what you can do is you can add parameters over here. After self, just put comma and you can write any variable, let's say name, and after that you can write age over here, and you can change this code, change this to name, and change 0 to age. And after that, what will happen? Now, if you run this, you will get error. Why error? Because you have not passed the arguments over here. If you write parameters over there, then whenever you are initializing the object, you are creating the object, you need to pass the values of that parameters in the form of arguments in the object. Now, what are the values which we need to pass? We need to pass the name and age of the student. So what I can pass here, let's say I am passing here Alice and 20. So now what will happen? It will not print an empty, and it will not print 0. Instead, it will print like this, alias 20. So now what is happening? When you are using the parameters, this name will be taken from here. It will come over here. After that, it will be taken. It will come over here, and this value will be stored in self.name. Self.name means self means the object name. So s1 dot name, this value is stored here, s1 dot name, and then self dot age is equal to age. This age will go here. After that it is used over here, and this value is stored in self dot age. Self dot age means s1 dot age. So s1 dot age means 20 now. So this is a simple meaning. Another example of explaining self also. So self means the current object. Now what is the current object? In case of s1, we are having s1 is the object. So instead of self, you can imagine that s1 is the object over there. So s1 dot age is equal to age means 20 will be stored in s1 dot age. So this is how you can initialize constructor using parameters and as well as without the parameters. So I will come to notes over here. So this is what I have explained, and after that constructor with parameter. This is also I have explained with the example of student only. I have explained this example, and after that we are having instance variables. Now what are instance variables and instance methods? So here definition is given variables that belong to each object. that are instance variables, and methods work on instance variables that are instance methods. So let us understand this both concepts in detail. I will go to GPT. I will go to Chat GPT. I will say to sorry. I will say it to explain instance variables. So I will just type over here explain instance variables. Now see over here. What are instance variables? Instance variables are variables that belong to a specific object of a class. Each object has its own separate copy of these variables, so changing one object's instance variables does not affect another. So what does instance variable means? Instance variables are the variables that belong to a specific object. Now, the variables that belong to a specific object that are known as instance variables. So what we are doing in the constructor over here, we are initializing instance variable. Self dot name is equal to age means this is the instance variable. So self dot name is instance variable. Self means the object name. Whenever any object will be using this, then that current object will be known as self. So self means like in that case we are using s1 as the name of the current object, then s1 dot name will be the instance variable in that case. So s1 dot name belongs to the object s1. So that is instance variable of the object s1. So in same way, it is written here that self.name and self.age are instance variables. Every student of object will have its own name and age. So there may be S2, S3, S4, maybe S100 also. So that will have their own instance variables like S1 dot name, S2 dot name, S3 dot name. So that name variable will belong to different objects, so that is why it is known as instance variable. So it is instance variable of that object. So same is written over here with this example. And after that, we are having how we can modify instance variables. You can change an instance variable after creating the object. Now, for example, we have passed the value alias. Now, how can you change that? When the object is created, in the creation of the object we have passed the value alias, but now you want to change the value. So how you can change that? You can write the object name dot name. So you have written the instance variable, and after that you can put equals to and then write the another value of that. So whatever value you will write here, it will be changed over here. So that value will be printed whenever you call that object, that instance variable. Now, what is the difference between instance variables and class variables? Now, what is class variable? Any variable that is written inside class outside the function is known as class variable. Now, what is the difference between class variable and instance variable? Instance variable is written inside a constructor. So what is the difference? Class variable shared by all objects. Instance variable, each object has its own value. As you can understand from here that self.name will belong to one object only, the current object. So it is an instance variable. It belongs to one specific object. But school equal to ABC school belongs to all the objects. Any object that is created that can have this value school. So s1 dot school and s2 dot school will be same. Why same? Because this variable, this attribute can be accessed by every object of the program. But anything written inside in it, self.name, self.age, anything that will be used or that can be called by the that particular object only. So one particular object can have one value, one instance variable. So this is the difference, that class variable is shared by all objects, whereas instance variable is shared by not shared. Each object has its own value. So what are the key points over here? Instance variables belong to individual objects, not the class. So this is very important point, that instance variable belong to individual objects, not the class. So do not mix up both the concepts over here. They are usually initialized in the init method using self. Every object has its own copy of instance variables. Modify an instance variable of an object does not affect the other objects. So one more example is given over here. So this is all about instance variables. Now I hope that you know all the concepts of instance variable. Now what are instance methods? Same way I will go here. I will write explain explain instance methods. Now, what are instance methods? Instance methods are methods that operate on a specific object of a class. They use the self parameter to access and modify the object's instance. So, what are instance methods? They are the methods that operate on a specific object. They use self parameter to access and modify object's instance variables. Now, here it is written class name, after that def method name, self method body. Self reference to the current object instance variable can access both instance variables and class variables. Now we have an example over here. It is given constructor is given over here with the parameters name and marks, and we are initializing self.name is equal to name and self.marks is equal to marks. After that, we are using a method to print. We are passing self in this, and after that we are printing self.name and self.marks. Now what is instance method? This is an instance method. Why? Because we are using self.name, self.marks, and we are passing self over here. So what is the meaning of that? Every object will have different values uh, for each other. For example, we are having this object over here, student. We are passing Elias and 90. So name is Elias. Self dot name is Elias will be printed over here, and in the self dot marks 90 will be printed. But if I say one more object is here, S2 is here, equal to student Rahul comma 20. So what is meaning of that? When this function is called with respect to that object, here we are calling x1 s1 dot display. When I call s2 dot display, then that values are printing that are initialized when the object is created. So this is the meaning of instance methods. It is same as instance variable, but this is the instance in case of functions. So how you can modify like these modifying instance variables that I have that we have done earlier. So moving to the next concept, now we are having four pillars of OOPS. We are having four pillars of OOPS. I will explain over here. OOPS have four principles. What does OOPS mean? Object-oriented programming. So object-oriented programming have four has four principles. So what are those? First is encapsulation. Next one is polymorphism. Next one is abstraction. And one is inheritance. So we will see what these four means one by one. So we are starting with encapsulation first. So what does encapsulation means? Encapsulation means combining data and methods into one unit, a class, and controlling access to that data. So encapsulation means nothing but combining of data and methods. Wrapping of data and functions or data and methods is known as encapsulation. So let us understand this concept with the help of one example over here. It is given that class bank account definite self dot balance is equal to balance def deposit self dot amount self dot balance plus is equal to amount. Withdraw function is there to minus to subtract out the amount from the balance. So these three methods are very clear. The first one is the constructor, second one is the deposit function to add the amount into the balance, and third function is to withdraw to decrement to decrease the amount to subtract the amount from the balance. So here is one real life example over here. We are having one ATM machine and you interact with the buttons, not the internal banking system. Let's say what is the example means that you interact with buttons but not with internal banking system. Now, what is the main purpose of encapsulation? Encapsulation protects data from unauthorized access, control how data is accessed and modified, improve code security and maintainability. So these are some of the features of encapsulation. Now we are having one example without encapsulation. So what is happening? We are having class bank account, and then we are having constructor that is initializing balance to balance. After that, we are creating one variable account is equal to bank account, and then we are initializing the object with 1000 as the balance. And after that, here we are directly modifying the balance. Account dot balance is equal to minus 500. So what we are doing here, we are directly modifying the balance and we are decrementing it by 500. So when we print balance, not decrementing, we are just changing the value to minus 500, and after that we are printing the balance and we are able to make the changes. Now, here anyone can set the balance to an invalid value. So to prevent this program, we are having encapsulation. Now, Python using naming conventions to indicate that an attribute is intended to be private. Prefixing a name with double scores triggers name mangling, making accidental access more difficult. Now, what does this mean? Let us understand this with the help of example over here. We are having the same balance function. After that, we are having deposit function, and after that, we are writing get balance function to get the balance, the current balance. Now, when we are now creating the object with the balance 100,000, so now we are depositing 500 we have deposited. Now, what will happen when we try to get the balance? We are getting correct balance. So here we cannot change the value. Here it is, we are having different functions that deals with the data. So what is the meaning of encapsulation? Wrapping of data and functions. So the data is here with the balance, and then the functions are used to modify that. You cannot directly modify this. So what is the use of double underscores here? It means that it is given over here. It is a naming convention to indicate that an attribute is intended to be private. So it means that the attribute is private over here. It cannot be changed from outside. The balance cannot be accessed directly using account dot double underscore balance. You cannot access this and you cannot modify this at the same time. So this is the meaning of that. Now, how we can access the private variable? Now you have written over here like this, and after that you are returning this. But now how you can get it out? You have to create a function. Create a function. Let's say get name that returns that attribute or let's say variable, whatever you want to call that, and then only you will be getting the output. Otherwise, you will not get the output. As here you are creating the object and you're writing calling the that function get name, then only you are getting. But if you try to print it directly, then you will get error, attribute error. Why? Because it is a private variable. Using double underscore in front of the attribute name makes it private. Private means the access is limited. Only you can access this value inside this class. It cannot be accessed outside the class. To access it outside, you should have functions that return it. So then only you can access it outside. Now, what are the advantages of encapsulation? Data hiding. Firstly, internal data is protected from direct modification. We are having controlled access. Methods can validate data before updating it. And we are having better security, reduces accidental misuse of object data. Then we are having easier maintenance, internal implementation of can change without affecting external code. So these are the advantages of encapsulation. Now, what are the key points which we are having? Encapsulation means combining data and methods into a class and controlling access to the data. So what we are doing here? We are doing nothing but we are creating functions to access the data, to modify the data, and we are not directly modifying the data to make it limited for the modification. After that, Python indicates private attributes using double underscores, which use name angling to discourage direct access. And we are having getters and setter methods that we are not covering in this. And after that, encapsulation helps make programs more reliable, secure, and easier to maintain. So these are some of the features, some of the advantages of encapsulation which we have done so far. So you can try out this code. You can simply write the same code, or you can have the another example from ChatGPT. You can have the program and try to write it by yourself and try to understand the things how it is working. Now, the next thing which we are having is inheritance. So what is inheritance? One class acquires properties of another class. Let's say one very very old example that everyone gives, that inheritance means like you are having genes from your parents, so you are acquiring some of the properties from your parents. So same way we can have properties of one class to another. Let's say this is a parent class, so we are having this as a parent class, okay, and after that we are having a child class over here. So this parent class is having some properties. Let's say some properties, Z properties, this parent class is having. The child class will also acquire Z properties. So whatever the parent is acquiring, that properties will be acquired by the child class. So this is the simple meaning of inheritance. So let us understand this in detail, in more detail. We try to understand this with the help of one example over here. The syntax is written over here for the inheritance. We are having class, we are having class animal. Then we are writing inside that class def speak one function which is having self passed, and we are printing animal sound. After that, what we are doing? We are creating one more class here, class dog, and we are passing this class to that. When we do like this, when we pass one class to another, now this becomes the parent class and this becomes the child class, because we passed animal as the parent class to the child class, that is dog. Now when we write def bark self and we are printing bark, now what will happen? We have created one object over here, d is equal to dog, d dot speak and d dot bark. Now, d dot speak is the function for dog, sorry, function for animal. So dot speak is the function. Speak function is mainly created inside the animal, so it belongs to animal. But the dog, the class dog can also access it. How? Because we have written the parent class inside the child class. It means it will acquire all the methods of these, and we can anytime call that method with the help of the object of the class of the parent class, sorry, the child class, and we will get the output same. So speak function just printed animal sound, and after that the bark function is printing bark. So we are getting the output same. So this example helps us to understand what is the meaning of inheritance. We are having some real life examples as well. We are having a vehicle and the child here is the car. So in the category of vehicle, we are having car as the vehicle type, and we are having bike as the vehicle type, we are having truck as the vehicle type. So these are the child classes, child classes, and this is the parent class. So this is the parent class. So what is happening over here? These are having some similar properties, similarities among each other, but it differs with their looks or anything you want to say. But they are having some similar properties, like they are used for transportation. For so here the purpose is same, the similarity is there among them. So this is the meaning of inheritance. They acquire the same properties, similar properties to that of the parent class. After that, we are having the types of inheritance. We are having single, multi-level, we are having single, multiple, and multi-level, then hierarchical, and then hybrid, possible in Python, though often avoided due to complexity. So, we are having these types. We will explore these types later on. Now, let us proceed to polymorphism. Now, what is polymorphism? One interface, multiple forms. Simple example is written over here. Let me explain you with the help of one real life example. Now, what is the general meaning of cell? If I write CELL, what is the meaning of that? We can have multiple meanings from this cell. The first one, let's say the biological meaning of cell is the biological cells. Let's say RBCs, WBCs, any. So let's say RBCs, red blood cells. So this is the first meaning of that cell. After that, we can have another meaning as the battery cells. That can be, let's say, electricity cells, or what you can say battery cell. Let us write battery cell. So we are having one word, and we can have multiple meanings, multiple use cases of that. That is polymorphism in simple terms. So what does polymorphism means? One interface, we are having one interface, let's say that is cell, and then we are having multiple forms of that. So these are the multiple forms of one interface. So this is the simple meaning of polymorphism. So let us understand in the terms of Python over here. We are having this example over here. We are having a class that is name is dog. After that, we are defining one function sound in that, and then we are printing the message bark. So same way we are having a class cat, and we are having the same function sound, and we are printing the sound of the cat. Then after that, what we are doing? We created one list we have created, and we have passed both the classes dog comma cat. So we have passed this, and after that we are doing for animal in animals animal dot sound. So we are just iterating over each element of this list, and we are trying to print the sound of that. So the objects are passed over here. The dog is the object of this class, cat is the object of this class. After that, we are passing that into list, and we are iterating over this list. So firstly, dog will come over here. This function is, sorry, this object will come. Now animal, this object means this object will be assigned to this animal variable. After that, we are doing sound. So firstly, this sound will be printed of dog, and after that, now it will have this object over here in the animal, and after that we are printing the sound function. We are executing the sound function. In the sound function, we are having the sound of the cat, and we are printing. So this is how we are having one interface, and we are having multiple forms of that. We are having one function, we are having one function over there, but it have different meanings with respect to different classes. So this is the meaning of polymorphism in simple terms. So one real life example is over here. You can read it out as I have given it already. Now we are having the next concept. The next concept. Now we are having the next concept, abstraction. So what does abstraction means? Abstraction means showing only essential features while adding implementation details. Let's say you are having a car. In the car, you know how to drive that, but you don't know how it is working internally, how the engine is working. Let's say you don't know that. You know how to drive the car. You know how to press the clutch, how to apply brake, how to accelerate, how to turn it left or right with the steering wheel, but you don't know what is happening internally. So this is what abstraction is. You know the outer details, how to run that, how to drive the car, you know, but you do not know internal things like how the gear is shifting, how it is the brakes are applied, how the acceleration is given. So you don't know the internal features. You don't know how the engine is working, how the lights are turning on or off, from where the wires are going to where. So you do not know the back end details. So this is what abstraction means. So abstraction means showing only essential features that are required while hiding implementation details. So same example is given, but I gave to you that driving a car, that example is given. So this is how abstraction is used. So this is the syntax of that. From ABC, import ABC. This is the file, the package, or you can say the module that we are using. From ABC module, sorry, from ABC, yes, from ABC module, we are importing ABC method, and after that we are using abstract method. So now whenever we create a class, we will pass this function, or you can say this ABC I will pass over here. You have to you have to be sure with the syntax for the abstraction, because it may be confusing sometimes. We are using small letters ABC, sometimes we are using capital letters ABC. So you should know where to use which. So you will learn it when you practice it 3 4 times. After that, you will get where to write word 3. Now, the next thing is we are creating a class, and then we have to pass this ABC over here. And after that, we need to write at the rate abstract method. Whenever we will try to create a method, we need to specify that. And after that, we are creating depth area, and we are just passing into that. After that, we are creating another class, circle, then shape. And after that, we are having depth area again, and then we are printing area of circle. Now, what is happening over here in this example? No, firstly we are importing this. After that, we are creating an abstract class. After that, we are declaring abstract method by at the rate abstract method. Then we are defining the method and we are just passing. So every class that inherits from shape must implement the area method. Pass means there is no implementation in the abstract class. So think of it as a rule. Every shape must know how to calculate its area. That is a simple rule over here. Now how to create a child class? Like we are creating inheritance. Same way we will write class, then class name, and then we will pass the parent class name, that is shape. And after that, we are defining now class inherits from shape, and after that we are defining one method over here, def area, that is printing area of circle. Now after that we are creating object c is equal to circle, c is equal to area. So what will happen? Area of circle will be printed. Since circle implemented the abstract method, Python allows its objects to be created. Why is this called abstraction? Showing only the required functionality while hiding implementation details. So this is how you can use the abstraction. One more example is given over here. We are having the class shape that is already created. We are writing rectangle over here. We are then writing printing length into breadth. After that, we are having triangle 1 by 2 into base into height. Now every shape has an area method, but each calculates it differently. Here is one real world analogy. Imagine a TV remote. The remote has a power button. You press it without knowing how the internal TV circuit works. So button is abstract method, that is power, that's the power function, and internal electronics is implementation. So whatever you do here, that is implementation, and whatever you show here, that is abstract method. Now what happens if the child class doesn't implement area? Now what will happen if the child class doesn't implement area? Let's say we are passing. Now we are having type error. Can't instantiate abstract class circle. Now Python prevents creating object because circle didn't follow the rule defined by the shape. So we are defining one rule here, that this class must have this function. If this class will not have this function, then you will get the error there. So these are the rules. Whatever you write in abstract method, The function name, whatever you define here, you have to define in the child class as well. If you don't do that, you will get error for sure. So this is all about abstraction. We have done all the four pillars of object-oriented programming. We have done it in a deeper depth, or maybe we can explore that more, but we can do that later on. Now we are having some real world examples. Student class, we have done it many times. Then bank account, deposit, withdraw, check balance, we have also done this. Then car, we have also discussed this. And then we are having employee management system that reviews here can be name, salary, department, and methods can be show details, increment salary, or anything. Now, what are the common beginner mistakes? Forgetting self is the mistake that everyone does. And after that, forgetting to create objects, confusing class and objects, using instance variable without self, and expecting constructors to be called manually. So now we are having one mini project over here, library management system. So we will do some project at the end of this series. But for now, you can practice this. You can try creating this. After that, we are having some practice questions, which you can see, or you can go to ChatGPT and get the questions from there. Practice that yourself. Increase the level. Again, practice. Check the code from there. Learn from your mistakes, and this way you can learn by yourself. Now we are with the lecture summary. Today we have learned about OOPS, procedural programming versus OOPS. After that, classes, objects, self keyword, constructors, then instance variables, instance methods, encapsulation, inheritance, types of inheritance. After that, polymorphism, abstraction, and then we have seen some real life OOPS examples. So this is all about today's lecture. Thank you.